Welcome back to our next make, where we're in the shop again to tackle a growing problem.
As you can see, we have a collection of hardware that's just getting out of control. We even have cups of screws and bolts that just need a home. As we searched for inspiration, we found a bunch of designs that seemed really functional, but we were aiming for something a bit more fun for our space. Just like we did with the drill bit storage, it was functional and fun. We brainstormed designs that had a grid-like quality, and pretty quickly thought of the reactor cooling vents on the DeLorean time machine from the best trilogy ever.
The first thing we did was decide on the size of the project. We knew we wanted it to be big enough to hold a bunch of hardware and to capture the cool contours of the DeLorean. So we jumped into SOLIDWORKS for Makers and started modeling. We inserted a reference picture and then built feature after feature to get the model to take shape. Once we were happy, we sliced it into layers, and then made a quick drawing of all the parts so we could verify they'd fit on a single sheet of MDF. We used our CNC router to cut out the parts. Watching this machine bring a design to life is always fun, especially when it's carving away intricate details that would be challenging to make using traditional tools. I used a spiral upcut bit for all of the tool paths because I wanted to help the dust collection extract as much of the fine MDF dust as it could. Unfortunately, I still had to do a bunch of vacuuming with the shop vac. The upward twisting of the bit also created fuzzy edges that we needed to sand down. With hindsight, I could have avoided this by using a spiral downcut bit for the first pass like I do when I cut plywood.
This had to be the most satisfying dry fit so far. It also gave us confidence to move forward. But before we could glue anything together, we roughed in the curve on the side of the car. With a piece of paper taped in place, we created a template by drawing a curve that fit the MDF layers. After cutting it out, we used it to draw the same curve on each side. Then, Sal rough cut the pieces at the bandsaw. Because they were so awkwardly shaped, he had to use a few scraps and a speed square to safely hold the pieces in the right orientation. Now, layer by layer, we can apply glue and then add a few brad nails to hold things together.
It was really exciting to see the car start to take shape in front of our eyes, but we were reminded of a fun fact when gluing up many layers like this. The tolerances on each MDF layer, plus the thickness of each glue layer, really add up, and it'll make any part like this crosspiece too short. That's why, unlike what we did, you should always cut parts like this to fit after the layers are glued together. To remedy this, we cut an L-shaped shim that also acted as a straight edge to remove the bow in this piece of MDF. That's something else we learned in this project. If you machine away some thickness in the middle of a long, narrow piece, it'll bow on you. We got creative with some plywood scraps and a few shims to clamp the shelf in place while the glue dried. We built out the backside of the rear panel with a series of small pieces. We'd first mark out each piece's length at the panel and then cut it at the miter saw. Using this approach of taking field measurements of each piece as we went meant we could get every piece to fit precisely and install them with glue and brad nails. Once the whole subassembly was built, we used it to mark our glue zones on the plywood panel and then flipped everything over to drive in screws from the back. To install the bottom of the bumper, we ripped MDF to width and then glued it in place. We added a few screws from the back for extra strength.
The license plate was one of the first things we made, and we asked our viewers to choose between a flat version or a version with raised letters. And everyone agreed the raised letters were better. On my Mac, I used Xdesign through a browser to model two versions of the plate. Just like Sal did with the DeLorean, I used a reference image to get the proportions and font face just right. We printed the plates out on our Bamboo 3D printer using its multicolor capabilities. We printed the first plate face down with the color changes on the bottom layer. We really liked how smoothly the different colors came together on the perfectly textured surface. As for the second print, the bubbled up letters looked amazing, but the rest of the colors on the plate seemed gapped and sloppy. So we used our viewers' advice and printed out individual letters and glued them onto the flat plate. It really turned out great. Best of both worlds. To add more storage capability to this build, we added a drawer to the back of the license plate. With super glue, painter's tape, and clamps, we attached the 3D printed drawer to the license plate. As a fun nod to the movies, we included a radiation hazard symbol to the inside of the drawer, which will make more sense when you see the end credits scene.
Once the glue was dry, we could start refining the shape of the body. We used a file to sculpt a smooth, curved surface. Then we worked on finishing up the bumper. We routed a cove in the top piece to mimic the transition from the body panels to the bumper on the actual DeLorean. Then we ripped a shallow taper on the face of the bumper to give it a subtle flare towards the bottom. With a bit of rounding over with a router and some more hand sculpting, the bumper was complete. Now we could begin smoothing out any imperfections in the build. We used wood putty to fill in nail holes and even out the transitions between each layer line.
The plutonium chamber is one of my favorite parts of this build. It incorporates 3D printing and laser cutting. Plus I got to make this really cool prop. And if you stay till the end, you'll get to see a cool upgrade. With 3D Play, a web-based viewer on the 3D Experience platform, I could check out the exploded view on my phone. As I modeled, I thought about how I'd orient this on the 3D print bed and made design choices so that I could completely eliminate support material. This really saved time. I also chose to split the design into 2 main parts so I could easily install LEDs and make way for that after-credit scene surprise I mentioned before. I cut the little trapezoid-shaped pieces out of white acrylic and used super glue to hold them in place. At one point, Sal casually mentioned that it would be cool to be able to insert a plutonium capsule in the chamber. So I took on the challenge. It was so much fun to figure out how to craft this together. I had a roll of clear mylar hidden in the depths of our makerspace that was perfect for this job. With a few shapes cut from an 1/8 inch or 3mm thick sheet of clear acrylic, I was ready to put it together with the help of some tape. An acrylic glue does a great job seeping into all the tight joints and fusing the pieces together. For the vial, I cut up a red boba tea straw, stuffed in a roll of clear mylar, and applied a yellow vinyl sticker with the hazard symbol cut into it. Voila! A vial of plutonium protected in a capsule fit for the chamber.
It was a really fun challenge trying to balance the aesthetics of the exhaust ports and making sure that they still functioned as cubbies. To keep the cubbies at the appropriate scale, we designed them out of 1/4 inch MDF. Using the full-scale drawings from SOLIDWORKS, we cut what we could on the CNC, but this only gave us dados on one side of the center partitions. Instead of setting up for a 2-sided CNC operation, we used the table saw to make the dados on the opposite side. We set the blade height and fence position using the existing dados and then just flipped the parts over to cut the other side. We ripped the shelves to width at the table saw and then cut them to length at the miter saw. Then we turned our attention to making a few beveled cuts on the top pieces. We used one of the side pieces to set the angle on the blade before making each cut. Some simple wood glue and a bit of tape to act as clamps were all it took to assemble the vents together.
It was important for us to create a set of realistic taillights. Acrylic was the perfect material. It made the surface smooth and allowed light to come through. We extracted a DXF directly from Sal's SOLIDWORKS model and used it to laser cut all of the necessary pieces for all the different colored acrylic sheets. Again, with the help of the acrylic glue, we attached the pieces to a white acrylic backer. This not only gave us a nice stable surface to attach to, but also acted as a great light diffuser to help the whole taillight glow when the LEDs are on. Since the acrylic glue is so runny and not viscous, it dripped everywhere during application. So if you use this method, make sure to quickly wipe up the material as you work. I wasn't fast enough and had some spots left that was quite hard to take off afterwards, even with acetone. Also, make sure to work in a well-ventilated space and wear a respirator. The smell from the acrylic glue and acetone are quite noxious, so stay safe. We 3D printed a few shallow drawers with compartments that lined up with the taillight grating. This time we used super glue instead of acrylic glue since we were attaching PLA to acrylic. It may have worked either way, but we knew super glue would do the job.
It's always exciting when a project reaches the stage where you can start to prime and paint it. We sprayed on a coat of primer that seemed to work well on the original flat MDF surfaces, but the machine thickness faces seemed to soak it right up. We sanded lightly between coats of primer, but things always still felt a bit fuzzy, so we brushed on a coat of Kills primer. This gave us the surface finish we were looking for, so we jumped right into painting. We of course had to mask off certain areas to keep the colors where we wanted them, but it was awesome to see the project come to life as each color went on. The black looked great, but the metallic finish was remarkable. It looked even better when we peeled off the last bit of masking to reveal the 2 colors side by side.
My original thought was that we would stop the build right at the bottom of the bumper, but Chinley convinced me that it wouldn't look right without the tires. I think she was right.
I foreshortened the tires so they'd make sense on the build, and cut a tread pattern that closely matched the one found in the movie. Each tire was designed with 2 countersink holes in it, and then 3D printed. We used the holes to screw the tire onto the tab we created in the back panel.
Even though having a bunch of individual cubbies is great, it's also nice to have a wide open space to store things.
The compartment itself didn't require much fussing, but we did take care when installing the hardware. We simply surface mounted the magnetic latch that holds the door shut and screwed on a basic handle we cut out of a piece of scrap. To give extra strength to the hinges though, we first routed recesses into the housing and into the door. Then we used extra long screws to ensure they were firmly gripping into the MDF.
Off camera, we ran a strip of LEDs through the build to light up various compartments. Then we attached the fusion reactor with 2 screws and glued on the reactor vents. The whole project is held to the wall with a French cleat. And then it's loaded up with all of its accessories.
This project is a perfect example of why we make things. I don't know anywhere else that you can get a hardware storage rack that looks like a DeLorean.
Next time when you make something, think out of the box. See if you can make something fun and functional.
Thanks so much for watching. We'll see you on our next make.